Okay, good morning to all of you, and we are starting the second year program. Hmm? We are starting the second year program, and as I told you, I am commencing it with atomic structure. Atomic structure you have studied in the in chemistry in detail, and this chapter is also included in the physics portion of second year. So whatever I am going to teach, you just have to properly listen, and it will be a sort of a revision for you. And more importantly, for you and me, you see, one important chapter will be completed, right? So I will take classes till March 9th, and that's the time that all of you have given me. So after that, you have some practical exam and things like that. I will not bother you. And test 3 solutions to be discussed, and test 4 to be conducted. Test 4 discussion, we will do it after 9th at some convenient date. Okay, one day you write and we will do it. We will complete it. Yes. Definitely. For whatever reason, you had special classes, so therefore we could not conduct the test, but we will go ahead with that. Okay? Well, students, so this atom as such is something which all of you know. I don't have to elaborate much. But what I would like to appreciate from all of you is that treat this atom as a concept. Very important. Okay, you treat this as a concept, and whatever diagrams you see in all the books, like this, okay, or diagrams like this, okay, because right from 8th standard we have been seeing these diagrams. So some students might have got the impression that, oh, there is nucleus here and there is electrons which are revolving around it like this in a very disciplined manner in its orbits. So please take this myth out of your head. Okay. So what you now have to understand is there is something called a concept called atom. So in a small space, you have large concentration of uncharged particles. We call them as nucleus, which mainly consists of neutrons and protons. And if you say this is nucleus, around this you have swarm of electrons which can move anywhere like this. It can move anywhere like this. It can move like this. So it is encircling. It is moving around the nucleus. Okay, but there is no fixed path for it. Hello friends, are you getting me? Yes. There is no fixed path for it. Right? I hope all of you have this idea. Yes. Okay, hello, please respond. Yes. They don't have a fixed path. So that's how you can see. So, theoretically speaking, the electron can even be at infinity. Theoretically speaking, but it will not be like that. So they will be moving close to the nucleus, but there is no fixed path. So keep that in mind. Thank you. Keep that in mind. So it will be a swarm of electrons moving around. Okay. Please have that concept to begin with. And second thing is, science is understanding science itself is very, very important, and not just from the point of view of oh, I am going to learn about atom, but the way science has been developed. The way science has been developed itself is a marvelous thing to appreciate and understand. Because just imagine, way back in the 19th century, say somewhere in around 1800. So science was just developing, and at that time, you see, the people, they used to see many different types of materials, they were not using the word compounds and all then, because atoms was not there, but they saw different types of substances around them, different types of things around them. So definitely, a thought will come to their mind. So Dalton started this whole process somewhere in 1800. So in 1800, he came out with a theory, to be very specific, 1808, saying that there is a smallest particle of the matter. Smallest particle of the matter which is not divisible further. And you go on making, you take some matter and go on making tukdi until you get the smallest particle, and he called that smallest particle as atom. And he says when two matter is reacting chemically to form a new matter, these tiny particles, tiniest of the particles, they will interact and then it is formed. So that was his theory to begin with, and I think all of you know this, right? All of you know Dalton theory, right? So individual particle. Now I think all of you also know, that Dalton's theory failed, right? So why did Dalton's theory fail? Come on, somebody tell me. Loud. After discovery of protons and electrons is what Dhimant is telling. Fine. Subatomic particles. Okay. So the Dalton theory failed. That's how it all began. Any other reasons for Dalton? Yeah.
Sir, when chemistry also said there were ionic particles and charges moving around, and Dalton did not constitute for those charges on his theory, sir. So his theory failed.
No. One account is, Dhimant came out with an idea that the day electrons was discovered, then Dalton theory failed instantly. Why? Because he had told it is indivisible, and they saw that it is divisible. That is, it has got subatomic particles, and therefore it can be further divided. That is one of the reasons which Dhimant has given. Any other reason for the failure of Dalton theory? Well, there are other reasons also for that. Okay, and mind it, proton was discovered much later.
Yes.
Right? Proton was discovered after Thomson's theory.
Yes.
Right? So therefore, you see, Dalton theory was every material is composed of minute particles known as atom. Atom is indivisible and cannot be subdivided. It can neither be created nor destroyed. All atoms of same element are identical physically as well as chemically. So here you see, all atoms of same element are identical physically as well as chemically. This was also defeated.
Yes.
Yes, sir.
Okay, keep this in mind. Whereas atoms of different elements have different properties. Fine. The atoms of different elements made up of hydrogen atoms. Okay, this was also defeated. The radius of the heaviest atom is about 10 times that of hydrogen atom and is about 250 times the mass. The atom is stable and electrically neutral. Okay.
Yes, sir.
So here you see, all atoms of same element are identical physically as well as chemically. This was also defeated. Anyways, I'll just go through many reasons why the Dalton theory failed. So in 1808, Charles Dalton published the first general account of atomic theory, cornerstone of modern chemistry. The theory originated in his earlier studies of properties of atmospheric gases. So mark this year, it is very, very important for all of us science students, that 1808, okay, some 200 years ago, right. So then you see, electron was discovered by J.J. Thomson in 1897. See, you must understand that means for over 90 years, Dalton theory prevailed. That is, one generation studied the science in the belief that atom is indivisible. Okay, and science is like that. You see, many things that I have studied in my yester years today doesn't stand. Okay, the science has changed over the years. Okay, now electron. So, and you see, most of the discoveries have happened accidentally. Okay, most of the discoveries have happened accidentally. So here you see, Thomson was conducting some experiment and he discovered electrons. Of course, the scientific temperament or the people who are scientists, they are very genius. They somehow feel that ऐसा कुछ हो सकता है, ऐसा कुछ है. So they hypothesize, but then they try to prove that. Okay, and once it is proved, it becomes a theory. So he discovered it in 1897, and obviously since it's a subatomic particle, Dalton theory failed. However, I would like to bring to your kind attention that failures of Dalton atomic theory is also attributed to many other things, such as it is said that atom is smallest individual particle, but not, because electron was discovered. Failed to explain the affinity of atoms towards other atoms to form compounds. Okay, so why should the smallest particle of matter, from Dalton's point of view, should get attracted and form a new substance? That is formation of compounds. So Dalton's theory could not explain this. Okay, that's very important, because chemical reaction has to take place. Chemical reaction will only take place if the basic aspect is satisfied. What is that? There must be affinity. One atom should come closer to another atom, closer enough that these two atoms mingle and form a new molecule, what we call it as a molecule, and a compound is formed. A new matter is formed. Failed to explain the existence of isomers. Okay, because these were some things which scientists noticed, but Dalton theory could not explain this. According to Dalton, the atoms of same element are similar in all respects. Atoms of same element may differ. Because, you know why? Okay, so the nucleus can have more number of neutrons or less number of neutrons. What do you call this? Isotopes. Yeah. So Dalton could not explain this. Inability to explain difference in physical properties of compounds made from atoms of same element, and inability to explain the binding forces due to which the molecules exist. So these were some of the other reasons why the Dalton theory was failing. Over the years, scientists went on conducting experiments, and they were saying that if Dalton theory is to be believed, then why this discrepancies? Okay, so that is how things started. Anyway, students, I am sure you are not sitting there and writing down all this. Don't do all that. Don't do any writing work and all those things. Okay, because as you all know, I am preparing nice videos out of this, and it will be uploaded in the YouTube. And if at all you want to prepare notes or something like that, it's actually not necessary, because these are all the derivatives from wonderful textbooks. So you can always use the video, and you can pause it and you can read it. Right? You can pause it and read it. And a class of 1.5 hours, I am splitting it into classes of 20 minutes each, 20 to 30 minutes, so that it will be easy for you to look at it. I hope that RBD 63, 61 lessons that I have put, and that too in sequential order, it is useful to you?
Yes, sir.
Hello?
Yes,
Huh? I am seeing that many of you are seeing that. It's good. So you can suggest, something else I can do to make it better, so that I want the system to become more effective and efficient. Okay, that is why I am doing all this prayas, making the best use of technology. Alright friends, I suppose these were all quite simple. You have understood this. Something more did I teach you than what you already knew, or already you knew all these aspects? Quickly. You knew? Yeah, you knew. Good. But only thing is, you see, in the theory, if they ask you what are all the failure reasons, you have to write all these data. But one thing I fail to see is, most of the students, discovery of protons and electrons. See, you can see that proton was discovered much later.
Yes, sir.
Okay, so therefore Dalton theory failed before protons were discovered.
Yes, sir.
Yeah. Now Thomson model was given in the year 1900, because Dalton failed in 1897, then the Thompson model. Now this Thomson model, you see, this diagram itself is wonderful, because here he is saying that, well, there is a sphere, and this sphere, in that you have got electrons which are embedded. So this sphere is itself positively charged matter, and these electrons are loosely present in that. Okay, something like, what is the analogy he has given? Plum cake. Watermelon, plum cake, So these are all the seeds, loose seeds. He gave this model. So atom as a whole is electrically neutral. So he He said, well, there is equal number of positive charges and equal number of negative charges. And because the positive charge is present in the atom sphere is equal to the negative charge of the electrons present, atom is positively charged of radius so and so, in which the electrons are embedded in between. And the positive charge and the whole mass of atom is uniformly distributed throughout the sphere. So that's what he gave this, and most important is you remember this diagram, then whatever is written here will be remembered. Then quickly, the theory was always, put to challenge, and the spectrum of atoms cannot be explained with the help of this mode. Scattering of alpha particles could not be explained with the help of this model. Okay, I suppose all of you, I'll throw more light upon it in the next section. So, you see some experiments that were conducted, okay, they were seeing some waves coming out of it, and so Thompson model could not explain those waves, okay, like Lyman series and all those things, so he could not explain, and alpha particle scattering experiment also could not be explained by this model, and therefore this model was also questioned. And remember the timing, 1809 Dalton theory, then 1897 electron discovery by Thomson, and 1900 Thompson model, right? Now in 1909, okay, Rutherford discovered proton in his famous gold leaf experiment. Okay, that year is very important, 1909, and this diagram is extremely important. This graph and diagram and all is extremely important. I hope all of you are familiar with this diagram and this graph. Come on, quickly tell me.
Yes, sir. Sir, graph.
The graph also done.
Yeah, graphs also one student says he has done, but others might not have done that. Fine, it's okay. Now there is a graph here, etc. and all for this. So the experimental arrangement is shown very clear here. So there is a lead box. So there is a source of alpha particles. Alpha particles, as you know, helium. You knock off the electrons, so it becomes an alpha particle. And then, of course, many things are not shown here. There is, a potential difference created, so that these alpha particles from here are accelerated, and there is a very thin gold foil. Very thin gold foil is here, and this alpha particle is made to impinge on this gold foil. Now I am showing you only one ray. Now you please understand, there is swarm of alpha particles coming out of it. Swarm. That means the gold foil is here, and many alpha particles are going and bombarding it. Of course, not in full space, in a small area, but even there you see many of them are bombarding. Now question here is, why did he choose the gold foil? Why not some other material?
Malleability.
Excellent. It is highly malleable.
Yes.
Right. They wanted to make it as thin as possible. Okay, because they wanted to say, okay, let me have a layer which contains only one atom. That is, only one layer, only one planar layer which only contains atoms. Because if it is thick, means it will contain one atom here and one atom here. Many atoms like this. So it's only one layer. Of course, he could not achieve it, but substantially, penetration could be possible. That's why the gold foil was chosen. Another important property of gold is, AU. AU is available in its native form,
Yes.
right? So, you can get it. All other, see, iron and all, you will get it in its compounds only. You will not get it in its native form. But things like, gold, platinum, these are the metals that you get in the earth. They are in its native form. Okay, as you can see here, the diagram is beautiful. The alpha particle, some of these, you see, whatever arrows you see here, these are all the alpha particles that have penetrated and come out. Okay, these are the alpha particles which have penetrated and come out, and these arrows indicate see, all these are indicating the direction of the alpha particles that are moving, and these arrows, as you can see here, are indicating the path of the alpha particle after they have impinged. Okay, so this is very, very interesting, because see, just imagine, he is passing alpha and he sees some of the alpha particles coming out at different angles, and he also sees that some of them are rebounding. Okay, and to an extent that theoretically an alpha particle is coming back in its same direction also. That is 180 degrees. Okay, now careful study was made. Very, very careful study was made. And well, about 1 in 8,000 is repelled back. Some are deviated through a large angle theta. Most of alpha particle passes through, and the screen used here, ZNS, zinc sulfide screen. There is vacuum, gold foil, 10 to the power of -3 meters, and lead screen is given here, lead box is given. Now, the alpha particles or the scattered alpha particles is studied, and then they are plotted. Now, what you understand here is, for very small angle of theta, very much less than 90, okay, you will see large number of alpha particles. That is, you will find a large number of alpha particles for smaller theta, angle of deviation. And as theta increases, the number of particles deviation for the deviation angle goes on decreasing, and it almost touches 0 for the alpha particle which is returning back. I hope this graph is clear to all of you.
Yes, yes.
Well, students, you see, this graph is not included for the PU syllabus, but for the mains and NEET, it is important, and the relation is very important. You have questions on this because N stands for the number of alpha particles deviating at an angle theta.
Yes, sir.
And this is proportional to cosec to the power of 4 theta by 2. That much, if you remember, it is sufficient. Okay. So most of the alpha particles went straight through the gold foil and produced flashes on the screen as if they were nothing inside the gold foil. Thus, the atom is hollow. Few particles collided with atoms of the foil, which were scattered, deflected through considerable large angles. So few particles even turned back towards the source itself. The entire positive charge of the atom, whole mass of atom, is concentrated in a small center called nucleus. The electrons could not deflect the path of alpha particles. That is, electrons are very, very light.
Yes, sir.
Electrons. So therefore, you see, now the scientists started making an idea. What is it? See, imagine, there is something solid here, and then there is a hollow thing here, and again the next particle. That is, one nucleus here, one nucleus here. In between, it is focal. So that the alpha particle which hit this, it got deflected, and the alpha particles which came here, they got deflected. So you see, it's just like, when we throw a certain, you take so many marbles and throw like this, then you see the deflection, happens. So something like that. Excuse me. So the experiment observations, they were able to come to this conclusion. Okay, that there must be nucleus and there must be hollow space, and in this hollow space there are electrons. Okay, and these electrons are so tiny that alpha particle is huge compared to the electron. So it doesn't matter. It absolutely doesn't matter, because I remember once when I was very small, can we derail a train by keeping a stone on the railway track? Okay, bad experiment. So I went and kept a small pebble and see what will happen to the train. But then you see the train, as it moved, that pebble got crushed, heavy pebble, sand pebble, it got crushed. And one more pebble, it went off. So why? The momentum of the train was so huge, and this particle was very, very small to change any momentum of that. And therefore, the scientists concluded electrons are very, very tiny, and the whole mass is, mainly the mass is concentrated in the center, and they started calling it as the nucleus. Of course, neutrons was not yet discovered. Okay, only thing is they were able to say most part of the atom is hollow, and in the nucleus you have got positive charges, and it is massy. That's what we say. So Rutherford in 1911 proposed a new type of model of the atom. According to this model, the positive charge of the atom, instead of being uniformly distributed, this is in comparison with Thompson model, throughout the sphere of the atomic dimension, is concentrated in a very small volume, less than 10 to the power of minus 13 meters. See, these figures are very interesting. Is the diameter at its center. This central core, now called nucleus, is surrounded by cloud of electron rings.
Yes, sir.
That word is important, a cloud of electron rings. So Dalton's atomic theory, once again I am bringing Dalton here, suggests that the atom was individual instead, but discovery of two fundamental particles, electrons, protons, inside the atom led to the failure of this aspect of Dalton atomic theory. Right? So, completely Dalton theory was smashed. Because you see, if you see the development of science, whenever a theory is developed, there's a lot of challenges. But then, when a group of scientists proves it, then it has to be accepted. But then there is always experiments to disprove the theory. So until the theory is completely disproved, it still stays. Okay, and that's why when this experiment was conducted, Dalton theory was completely demolished. The individuality of the atoms are proved on, and atoms can be further divided into protons, neutrons, electrons. However, an atom is the small particle characteristic. You see, we had never heard of subatomic particles. So we know only protons, neutrons, electrons. Now there are mesons, right? Even the nucleus itself consists of particles which are other than neutrons and protons. We never studied it in our days, but now you see, even there are subatomic particles, sub to even protons, neutrons, electrons. I'm sure you are aware about those things.
Yes, sir.
Hello.
Yes.
Yes.